After I finished a PhD, I went out to look for something challenging, and I found gravitational waves. It took us 20 years to build this detector just here. And in doing that, we learnt all sorts of exciting new physics. We also discovered that we were dealing with with the quantum properties of matter. We never realized that measuring vibrations in a big metal bar was quantum mechanics. And then all of the quantum mechanics led into our design of the next stage of the detectors, which were these huge laser machines. So our group made a very important prediction for LIGO in the year 2005. We predicted that the detectors that they were starting to build would be unstable, like a PA system becomes unstable and can start to whistle. And then we started working on ways of stopping the instability, and we tested ways to stop the instability. And 10 years later, LIGO observed the instability exactly as we predicted it. And then they asked us to help in controlling the instability. That enabled them to increase the power, which is like turning up the sensitivity, and turning up the sensitivity to about 1/8 of the full power that they were aiming for. But that was enough to bring enough sensitivity for detecting the first signals. What was discovered was a pair of black holes, one 36 times as massive as the Sun, the other 29 times as massive as the Sun, spiraling together and then turning around each other initially we found them at about 50 times a second, and then eventually going up to more than 100 times a second, these enormously massive things, but with size about the size of Tasmania. And then they finally merged into a single black hole and gave a vast gravitational explosion, which is the biggest burst of energy ever observed in the universe by humanity.